Just in previous lecture, we have learned how to find the confidence interval of our population's mean or normal distribution functions. But in this lecture, we will learn how to find the confidence interval for of the population's mean for any random variable. The thing is for any random variable. How to find how the confidence intervals or population mean. This means a population mean. This means the simple population mean. Suppose let's take we have any distribution x. This is the first thing, that it is any distribution. This is the any distribution. Okay, suppose let's take it follows some distribution f with population mean. Let's take with some population mean of mu and standard deviation of sigma. Let's take it has some population mean and some standard deviation sigma. Suppose let's take we have some observations of these random variables. Suppose let's take it some observations x1, x2, x3 dot 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 dot. Let's take it some observation up to x10. Now it's the random observed value, means these things are the sampled of some size. So this is the sample of suppose let's take size is size here n is equals to 10. Here the number of sample size is equals to 10. Suppose let's take that's examples we have taken and previous. Suppose let's take these data, this observed value are like that: 180, 162, 158, 172, 168, 150, 171, 183, 165, 176. Suppose these are the observed value of that of our population. Suppose let's take these are the random variable of the height of the student that we have taken in previous lectures. Height of the students. Okay, let's take this is the height and this is some observed value of it. Means this is the given sample of the distributions. Means these are the sample of the given distribution. These are the given these samples. We have given these samples for these distributions x. Okay, now the questions is that arise in our mind. The first questions that arise in our mind. Okay, so what is the 95% confidence interval of our population mean? Because if we know that if it is a normal distributions, then using by sample the normal tables we can find its confidence interval. But if we don't know anything of this distribution, then how we can find this thing? So now the questions is, what is the 95% confidence interval of this population, of this view, means of this confidence of this population mean, means of this population mean. This thing is the population mean sample. What is the 95%? It could be anything. It could be 95, 90, 80, 75. It could be anything. How to find this confidence interval? Okay, actually here in these cases we don't know anything of this distribution. Means just we know the sample size, sample observed value. We don't know anything of this mean. Means here we don't know. Here we Here we don't know the value of mu. Okay, just we have to find it, and just we have to find, just we are interested to find is to find its confidence interval. Just we have interest, we are interested to find it. How we'll find this thing? Now let's see. So if you just calculate the sampled mean of this sample value, so if you just calculate it, actually just before of this lecture I have calculated using my own calculator. If you calculated these things, then you can got the sampled mean. These things means what? This thing means sample mean. This thing means sample mean, and you got this value it will be 168.5 centimeter. This value will be simple 168.5. Okay, now there may occur two cases. Now let's discuss the case one by one. So there may occur two cases. So let's discuss first case one. So what is case one? Suppose let's take, we know the, suppose let's, in first case we know only its standard deviations, but we don't know about anything of our population mean. Suppose let's take, we know the standard deviations, means population standard deviations. Population standard deviation. Suppose let's take as an example 5 centimeter. Suppose in these cases we know the population standard deviation. Suppose let's take, and we don't know anything about our population mean. We don't know anything about the population mean. We don't know anything about this population mean. Now, the how will calculated the confidence interval in such cases? Now, let's see. So, because already we have learned the central limit theorem. So, what are actually central limit theorem says? If you remember the central limit theorem says that if x bar is a sample mean, if this x bar is a sample mean for any distributions, it not need to be a normal, for any distribution, then the sample mean are follows the normal distribution, then the sample mean are follows the normal distribution with the mean of population mean of the of our random variable x, and with standard deviation sigma by root n. Here small n is the sample size. Here the small n is the sample size. Here small m is the simple sample size. X bar is the sample mean for any distributions. So in these cases, that the examples I have taken here. So in these cases, what should be the sampled mean? This will be, I have taken sample size 10, I is equals to 1 to 10, xi. This value is simply 168.5 centimeter. This value will be simple 168.5 centimeter. Okay, because from the central limit theorem we know our any sample to mean, for any distribution the sampled mean always follows the normal distributions with the mean mu, means it is this population mean, and with standard deviations. By this we using this formula, we already know this thing, we have already known this thing. because these things are actually the sample mean. This is the normal distribution, this is the population distribution, this is standard standard deviation. Just write this thing. This is the sample mean, these are the normal distribution, means Gaussian curve, that's I'm talking about. Gaussian curve, this is the population mean, this is the population standard deviation, this is the population, and this n, this small n and this small n are actual the sample size. These are the sample size. That thing we have known. But here we don't know anything about our mean, and we only know the standard deviation. We don't know anything. Sorry, we have only known the standard deviation. Here in this case we have only know the standard deviation, population standard deviations, population size, this one, but we don't know about anything about our population. We don't know. We don't know it about it. Okay. Now, just from previous lecture, if you remember the previous lecture, if any distribution that follows the normal distribution, then easily we can find its confidence intervals from these distributions. We can easily find this from the for this distribution. For these distributions, we can easily find its confidence interval. How will find? By example, its mean is equals to mu for these distributions. So the if its mean is equals to mu, so its mu are actually lie on these regions. Just if you remember the previous lecture, if our distributions are Gaussians, look like that, and if its mu is here, then our 95% point are lie on this range, means two standard deviations range, in the range of the two standard deviations, its 95% points are lie on this range, means this value will be mu plus 2 sigma, this value will be mu minus 2 sigma, this value. So our mu are actually what for these distributions? What is the value of the sigma? Just raise this thing. I think this, just raise this thing. So the value of the sigma is what sigma is sigma by root n. Here the sigma by root n. So now here this value will lie on this range, means mu minus 2 sigma, this mu are lie on this range, means this x bar minus 2 sigma by root n divided by x plus root n. Means why? Because x bar here follows this for because x bar, actually this x bar is what? X bar are follows these distributions with mean this and this. So actually this, for this distribution, instead of using x bar here, is the x bar, this is the x bar. Okay, because x bar are the sample mean, because x bar follows these distributions, so you can easily conclude that our population mean lie on that regions, by simply using the center. Just if you look like this is these distributions are, these portions are actually look like these portions, means this is the sampled distributions, and this is the sampled distributions. So these things are actually look like means mu minus 2 sigma. mu plus 2 sigma. Okay, actually this is the sampled mean, so don't be confused about that. Just to remove this thing. Just remove this thing. Don't be confused about it. Because it's sample mean x. Don't here actually it will be mu, but the interval that lie on this way. If it is mu, if this okay, I think you got the answer from here. Means it's look like this type. Okay, mu or look like this type. Just because from this sample, from these formula are actually talking about, just we got this formula from the central limit theorem. I think you got the concept how this is a useful. These confidence intervals are, as the estimations of the confidence intervals are useful on this range, because actually this is the mu, actually one kind is the population mean, and on that range the mu will lie, and with a 95% confidence interval. So this interval will be, this will be with 95%, this value will be with 95% confidence. This value, I think you got some idea how this the population mean are estimated, means on that intervals. Similarly, for from the previous lectures, using the normal distribution tables, we can easily calculate it. 95% interval, 80%, 75%. That's as our requirement. We can easily calculate. I think the case 2 you have understand. If we know the standard deviation of our distributions, okay. But now the case now come to the case 2. Now let's come to the case 2. Now case 2. Now case 2, if we don't know the standard, in previous cases we do know the standard deviations of the population. Standard deviation means I'm talking about the population standard deviations, and we don't know anything about population mean. The second case, we don't know anything about population mean as well the population standard deviation. If we don't know the population standard deviation, this means population standard deviation, and don't know anything about population mean. Okay, we don't know anything of these two parameters. Just we know the sample top size. We know sample size. Suppose let's take its n. So in such cases, we will use the tree distributions, the concept of T distribution. We will use the concept of tree distribution. Means I am talking about the students T distribution. This means it is simple students tree distributions. I am not going to discuss it mathematical portions of the student T distributions. If you are interested, please go to the Wikipedia articles, then you can easily understand this. I am not going to discuss its mathematical portion. Now I'm just giving the hint how, in which situations actually the students T distributions are useful. I'm going to this concept here. So if you don't know the population standard deviations and its population mean, then in such scenario we will use the T distribution, means students T distribution. So the students T distribution are tell us that our sampled mean, that we have already known, the sampled mean are follows the student T distributions with n minus 1 number of degrees of freedom. Okay, this T means this T, actually speaking us, this is the T distribution This is the simple t distribution, and this n minus 1 means it's the simple degrees of freedom. This is simple the degrees of freedom, and this x bar are as previous, this thing as sample mean. These things is sample mean, sample mean. So in such scenario, we have. So in such scenario, that are things we have to. So now let's take what is the degrees of freedom for the student distributions. Now let's go to the Wikipedia article. Just see the picture from there. Then I think then you got some concept from there. What kind of look like the students distribution? Let's go there. I'm just taking this picture from the Wikipedia article, Wikipedia page. So if you just search it on Wikipedia, then you can easily find this kind of pictures, and they have easily elaborated this thing in a easily mathematical way. Just before after this lecture, just go there and read this article. You will understand this thing. So but let's try to understand. So what is actually the degrees of freedoms and how these things are related to our student distribution. So student distributions are look like our normal distributions. It's the similar kind of normal type of distributions. They have some differences, but we have seen the normal distributions. We have seen that in our normal distributions we have two parameters. In Gaussian distribution, we have two parameters, mu and sigma. Okay, parameters. But in t distribution means in students t distribution means students t distributions, we have only one parameter, that's called the nu. Only one parameter nu we have. So the parameter nu, that's the parameter nu are actually talking about the, if you increase the value of the parameter nu, if we increase the value of this parameter, that means our Picardness of the distributions are increased. Just see this first YOLO line. Just see this YOLO line. In the YOLO line here, nu is taking 1. So the see the Picardness. Is Picardness more lesser. If you increased 2, then just violet line. See this violet line. These things. If just blue line, if you new take the 5 blue line, and if you new take the new value is equals to infinitive, this red line actually is this red line. So this kind of, this is the simple the one student t distributions, and these value are actually called the degrees of freedom. These parameter are called the degrees of freedom. I'm not going to discuss step by step what is degrees of freedom and how these things are related to our curve, and why we changing this thing, and how does why this type of why these things are performing look like. I'm not discussing in details. If you're interested, please search on any mathematics in any statistics book, then you can easily find. I'm just giving the hint in which situations these distributions are actually useful. I'm going to give you this idea. So we will see there have only two type of cases. If we know the population standard deviations, then simple by using the central limit theorem we can easily find its confidence interval. But if we don't know the population standard deviations, then we will use the t distributions. Similarly, by these t distributions and from the t distribution tables, we can find its confidence intervals. As same as from as it is the same thing as that we have seen in the previous lecture. How to find by simple using the normal table, distribution normal table, how Gaussian distribution table, how we'll find the confidence intervals. Same things are all applicable on these t distributions, but only we have to use the t distribution tables. Okay, I think you got the idea. Okay, if you just summarize, conclude this thing. If you just conclude this thing, then Then what kind of just conclude this thing, conclude this lecture. The conclusion is, so estimate the confidence interval of the population mean mu of any random variable. The main thing is that the any random variable of random variable, there we have seen two type of case. We have two type of cases. So the first case is if we know the value of the standard deviation, population standard deviation, if sigma is known. If we know the value of the population standard deviation, then we will use the central limit theorem. By simple central limit theorem tell us that if it is normally distributed and its population mean is mu and its standard deviation will be this thing, by simple using these normal distributions and by simple seeing the normal distribution table, we can easily estimate our population mean. Confidence interval, easily you can estimate the confidence interval of our population mean. Okay, now the case 2. Now the case 2 that we have seen that if sigma is unknown, in such scenario you have to use the student distribution, student's t distribution with degrees of freedom n-1, where n is the sample size. N is the sample size. Simple using these distributions we have to estimate by using the student's t distribution table we are using. So I think you got the idea how these things for any random variables, how this concept, how these things are workable to estimate the confidence interval of the population means to estimate the confidence interval, how much confidence to find that if we don't know anything of our population. The first thing that we have to remind that for any random variable we don't know anything, we don't have any idea of our population. I mean population don't know anything. That's thing, first thing. We don't know anything of this, of the population. We want to find we only want to find its confidence intervals. Okay, we want to find its confidence. Now the questions that's come into the mind, sir, okay, everything is okay, how will find the confidence interval of the population mean, everything we will learn, but how will find the confidence interval of the standard deviations, how will find the confidence interval of our medium, how will find the confidence interval of our percentiles, how these things we can estimate. Now this is the big questions, how we will estimate these things. Only if you just only find the confidence interval of a population means, that's not a task. We have to, in somewhere we have to find the confidence on interval of the standard deviations. That's are also an important thing for our real world applications. So the questions that's come into our mind, that how to estimate the confidence interval for the population standard deviation means of any random variable, how to estimate the confidence interval for or median how to estimate the confidence interval for suppose let's percentiles, means suppose let's take 19 percentiles. 19 percentiles. How to estimate these things? So to estimate these things, that's our modern computers come into the picture to estimate. We can easily, these kind of distributions, we can easily find the confidence of our population mean. But to find the estimation, to estimate these things, to estimate the standard deviation, median, 19 percentile in every means I'm talking about the statistics. These are the statistics of our data. Means I'm talking to the statistics. Statistics. These are the simple statistics of our data. To estimate these things, computers, the iterative algorithms means to compute, the computers come into the pictures to calculate this. We will see how to estimate these parameters in the next lectures, but in previous days we have not sufficient amount of computational power. Okay, so in those days we only calculate the population mean, okay, just by simple using these theorems. But in nowadays we have huge amount of computational power, so by simple using this computational power we can easily estimate these things. So there I have the one technique. The technique is in general called this technique as the bootstrap confidence interval. Bootstrap technique. This technique are called the bootstrap confidence interval. Bootstrap confidence. We have seen this thing in the next lecture. Okay, by simple how this is a simple and iterative technique. By simple using the computational power, we by iteration method we will calculate the estimations of the confidence interval of the of any other statistics parameters. Okay, we will see this thing in next lecture. I think from this lectures you got the idea for any random variable how to estimate, how to find the confidence interval of the population mean. This is the population mean. I think this the idea behind this lecture is clear. Okay, so we will see these things, the how to estimate the confidence interval of the other statistics parameter by simple using the bootstrap confidence interval. We will see this thing in